Hello, so today I wanted to continue our study of systems of linear equations by going over a quick lesson on how to solve systems of equations algebraically via substitution methods. So a quick recap, in our last two videos, first we went over how to solve systems of equations graphically, and then we went over how to classify systems of equations. So if you can recall our first lesson, we went over that to solve a system of equations graphically, you would graph both equations and find the point where the equations cross. And that point would be the solution to our equation. But as we also discussed, this method has a major shortcoming, which is that it's very difficult to get an exact answer unless we graph very precisely using graph paper or graphing software. So, suppose we want to find the exact answer to a system of equations. Well, one of the methods we can use is called solving by substitution. So, suppose we're given two equations. Let's do y is equal to 2x minus 3. And let's do 3x plus 5y is equal to negative 8. So these, if we want to graph these equations, we may not be able to get a very precise solution. So there is a better way, and that's what's called substitution. So in substitution, we want to pick one of these two equations, and first we want to solve that equation for either x or y. So in this example, it's kind of a no-brainer. We want to solve the first one for y because it's already been solved for us just in the form that we're given, because we have y is equal to 2x minus 3. So we know that this is equal to y, right? So we also have a y over here, which I will underline in red. So since y is equal to 2x minus 3, we can substitute 2x minus 3 for y in the second equation. So what is this going to look like? So we don't do anything to the 3x, right? So we have 3x. Now we have plus 5, and then we have in parentheses 2x minus 3 is equal to negative 8. So I'm just going to underline the 2x minus 3 in red to just, again, reiterate that this 2x minus 3 and this y are the same thing because of what we're given in this first equation. So now it's like magic. Suddenly we have one equation and only one variable. And we can solve for that, right? So first we're going to use the distributive property, and we're going to get 3x plus 10x, because that's 5 times 2x, minus 15 is equal to negative 8. Now if we combine like terms, we can combine the x's. We get 13x is equal to, let's add 15 to each side. 13x is equal to positive 7, because we're adding 15 to negative 8. Now, if we divide each side by 13, we get that x is equal to 7 over 13, which, as you can see, that fraction would be very hard to discern from a graph. It would be very difficult to get that exact answer. So now we've only done half the work, because in solving for a system of equations, we have both an x and a y value. But luckily for us, it's not too bad. So we would want to take our x value, and we're just going to do substitution again. Since this is an x over here, we can substitute 7 over 13 for this x. So I'm just going to move over here, and we would get y is equal to 2 times 7 over 13 minus 3. And let's underline this x in orange so that we know that this is representing the same thing. So now, if we solve this equation, we get y is equal to 14 over 13 minus 3. So we just have to do a little bit of addition of fractions, which 3, if we multiply it by 13 over 13, we get y is equal to 14 over 13 minus 39 over 13. What's 14 minus 39? So that would be, well, first we can get 14 minus 39 over 13. We get, let's see, we would get, sorry, this is taking way too long. We'd get a negative 25 over 13, which is equal to our y value. So now we've solved our system of equations. So we can either leave our answer like this, where we have y is equal to negative 25 over 13 and x is equal to 7 over 13, or we could also just write our answer as a coordinate point, 7 over 13, and then negative 25 over 13. And that would be our answer. So not too bad, right? We're just solving one equation for one variable, and then we're substituting that into the second equation, like this, and then we get one equation with one variable which we can solve. And then once we get one variable, we can plug that back into either of the two original equations and solve for the second variable. So let's do one more example. So sometimes things aren't quite as easy for us. We could have an equation that looks like 2x plus 6y is equal to 18, and then we could have 4y minus x is equal to negative 2. So here, neither of these equations have been solved for us yet. So what we want to do is pick one of these two equations and solve for our variable, either x or y. So I say, let's pick this second one. And what we can do is, if we add x to each side, we get 4y is equal to x minus 2. And then if we add 2 to each side, we get 4y plus 2 is equal to x. So now we've solved this for x. So I'm going to underline this because this is equal to x. And I'll also underline this because we're going to take this and put it into this equation right over there. So if we do that, I'll draw, let's use green, another arrow to represent that we're using this equation. We have 2 times 4y plus 2 plus 6y is equal to 18. So again, it's just like magic. Suddenly we have one equation and one variable. So we're going to do the distributive property. We get 8y plus 4 plus 6y is equal to 18. If we subtract 4 from each side, we get 8y plus 6y is equal to 14. 8y plus 6y is equal to 14y, which is equal to 14. And then all we have to do is divide each side by 14. And what do you know? We get a really, really nice answer. We get that y is equal to 1. You really love to see that. So that is also going to make our next step really, really easy. Because if y is equal to 1, that means we can take this value, so let's use orange for y, and we can plug it in right over here. So we could pick this equation, we could pick this one, we could pick this one, or we could pick this one. It doesn't matter which one we choose. I'm choosing this one because it's already solved for x. So all we have to do is plug y into here and do this operation, and we'll get an answer for x. So if we do that, we would get 4 times 1, since y is equal to 1, and we have that y right over there, plus 2 is equal to x. And we just get x is equal to 6. So I can put a box around our answer to celebrate it. And once again, we can write our answer as a coordinate point if we want, 6, 1. So hopefully this will clear up some confusion, if there were any, on how to solve systems of equations using substitution. And substitution is a great tool because any time you are given a system of 2 linear equations, you can use substitution to find an exact solution to the equation. So in our next video, we'll go over how to solve systems of equations by elimination, which is a method that can be pretty handy when you're given 2 equations that might be difficult to solve by substitution.